Hello, welcome. Let's tackle this question on trigonometric graphs. So the question reads, complete the table below for the function y is equals to cos x and y is equals to 2 cosine half x. For the range is given there. X should be greater or equal to 0 or less than or equal to 360. So looking at the table, the two graphs that you're supposed to fill the table, you get 2 marks. The first thing would be to identify how the table is filled. When you look at these, the values are given correct to 2 decimal places. So we should go by that. We should not give to either 3 significant or any other form. We should stick to 2 decimal places. So let's begin by filling the table. So the first row where we have cosine of x, we're going to start to fill for 90, for 120, then 210, so on. So cosine of x in the column of 90, so we shall fill, we start with cosine. Let's begin. So we start with cosine of 90, and cosine of 90 will give 0, so we fill that on as 0. Then cosine of 120, negative 0.5, one will be negative 0.5. And then cosine of 210, will give negative 0. We've said that we're going to give this one. Let me correct these. And we begin. Cosine of 90, we've got that one as 0. And I write this one well. This one is 0. Then cosine of 120, negative 0.5. That is how we fill it, negative 0.50. Then the next one is 210, cosine of 210, negative 0.87. Then negative, this is 270, give 0. Then 330, that will give 0.87. This one should be 7. Let me erase these. The next one, we are through with the first row. Let's go now to the second row. And the second row is where we have 2 cosine half of x. So 2 cosine, and then we have half of x. So when x is 60, we get that one is 1.73. When x is 120, that will give 1. When x is 210, that will give negative 0.52. And then when it is 270, negative 1.41. And then when it is 330, negative 1.93. And that's all. And that is how you're supposed to fill that table. So let's now proceed to the next part of the question, where we are supposed to draw the two graphs. So let's draw the graphs of cosine of x and 2 cosine of half x. Now the scale is given. You're supposed to use the scale in the y-axis, 4 units to represent 4 centimeters to represent 1 unit. 4 centimeters to represent 1 unit. So that means for this is 1, this is 2, 3, 4. That is 1. So that is the meaning of 4 centimeters 1 unit. So 1, 2, 3, 4. That should give 2. Below, that is on the negative side. So 1, 2, 3, 4. That should give negative 1. Should give negative 1. Should give negative 1. And then 1, 2, 3, 4. That should give negative 2. Should give negative 2. So for every 1, 2, 3, 4, for 4 centimeters, that one should represent 1. So that is the scale in the y-axis. Now the scale in the x-axis is given by 1 centimeter 30 degrees. So this one will be 30 degrees, then this one will be 60, this will be 90, this will be 120, 150, 180, then 210, 240, 270, 300, 330, and 360. So that is what you're supposed to have. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Now let's now plot the first graph, which is cosine of x. So when x is 0 degrees, we have 1. Cosine of x is 1. So that is where we should plot. So when x is 0, 0 is 0, y is 1. So that is the first point. The second is 30, 0.87. 30, when x is 30, y is 0.87. We can't plot 0.87. So the best thing will be to approximate that to correct to 1 decimal place. This one will be 0.9. So 0.9, we need to understand the size of one small square. So if 4 centimeters represent 1, then 1 centimeter should be 0.25. This is 0.5, 0.75. That, then 1, 1.25, 1.5, 1.75. So that is what you should get. So 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, and so on. Then down, negative 0.25 is negative 0.5, negative 0.75, negative 1, negative 1.25, negative 1.5, negative 1.75, and finally negative 2. So below the x-axis, this is what you should have. Below the x-axis, this is what you should have, as you can see. And then after doing that, I want us to plot now these values. So 30, 0.9. So one small square, since 1 centimeter represent 0.25, so one small square will be 0.05. So after you get two small squares, that is 0.1. So 30, 0.9. So 0.9 will be, so 0.9 will be here. It will be there. Then 60, 0.5. So 60, 0.5. 90, 0. 90, 0 will be there. 120, negative 0.5. 120, negative 0.5 is here. Then 120, let's put that. 150, negative 150, negative 0.9 or 0.87. So 150, negative, this is negative 8.5 should be here. Negative 0.9 will be here. So let me go up here. So for 120, it was negative 0.5. Then on 50, negative 0.9. 180, negative 1. 180, negative 1 is there. 210, negative 0.9 be there. 210 to be there. Then 240, negative 0.5. 240, negative 0.5 be there. Then 270, 0. Then 300, 0.5. 300, so 300, 0.5 would be there. 330, 0.87. 0.87 would be here. We approximate that to 0.9. So this is what you get. 330, 0.9 will be there. Then 361. 361. Now we have plotted all the points. As you can see, they are the points. So we need now to join the points using a smooth curve. That is what I want to do. So I'll begin from here. So I want to begin from here. We join this point using a smooth curve. So we join from this end. Now you can rotate to ensure you don't mess up. So that is how it's supposed to all the curve should pass through all the points. You should use a pencil to do this. I'm using a pen simply because I'm just demonstrating. You should not try this. Always use a pencil in case of any mistakes. You can do a correction easily. So that is the curve y is equals to cosine of x. The next one that we want to draw is y is equals to 2 cos half x. We have the table y is equals to 2 cos half x on the same grid. So let's plot that, draw the curve. So when x is 0, y 2. So when x is 0, it is when x is 0, y 2. Then 30 is 1.93. So we approximate that. So we get 30, 1.9. 1.9. So this 1.85, 1.9 is somewhere here. So 30, 1.9 should be there. Then 60, 1.73. So 60, 1.73. We approximate that 1.7. 60, 1.7. So this is 1. So from 1.5 we need to plot 1.7. 1.7 would be here. 1.7 would be here. So you're approximating, instead of plotting 1.73, you plot 1.7, then 90, 1.4, 90, 1.4, 0.4 will be somewhere here. Always remember the size of one small square is 0.05. Then on 20 is 1. And 20 is 1. So 120, 1. 150 is 0.52. So we approximate that to 0.5. So 150, 0.5. 180, 0. 180, 0. Then we have 210, negative 0.5, 210, negative 0.5, we approximate that to negative 0.5, 240, negative 1, 270, negative 1.4, 270, negative 1.4, yeah, 270, negative 1.4, should be somewhere there. Then 300, negative 1.73, 300, negative 1.73. So approximate that to negative 1.7. be somewhere there, should be there. Then 330, negative 1.9, negative 1.93, so we approximate that to negative 1.9. So 330 is here, 330 negative 1.93, but we approximate negative 1.93. Then 360 negative 2, 360 negative 2. So that is those are the points as you can see them. You can see how the points are moving. You can see how the points are moving down to the last one. So we join again that one using a smooth curve. So there is the curve. So you can see the two curves there. So this is y equals to 2 cos I have x. So those are the two graphs. So that is basically how you're supposed to draw the two curves. So you can see them, they should be smooth, or the curve should pass through all the points that you've drawn. So that is how you're supposed to do the curve. So let us see how you're supposed to answer the questions. Part C, use your graph to determine part 1, the period of the function y is equals to 2 cos I have x. So we want to get the period for this curve y is equals to cos I have x. You can see that this is the curve. So the period is the angle that it takes to make one complete cycle. Now from the equation, there is a simpler way that we are supposed to use to identify the period given any curve of such kind of an equation. So if you're given y, let me make this one larger. If you're given the equation, let's say equation y is equals to either it can be cosine a cosine bx, or y is equals to a sine bx. Now if you have any equation of that nature, a is the amplitude, of that curve, and then 360 divided by b gives the period of the curve. So this is the easiest and the simplest way to identify the period and the amplitude of any given curve of this nature of this equation. So in this case, when you look at this equation, y is equals to 2 cos I have x, b is equivalent to a half, so therefore the period will be 360 divided by a half. B in this case is a half. This will give 720 degrees. That is the angle that you take to make one complete cycle. The next question is the transformation that maps the function y is equals to cos x onto y is equals to 2 cos I have x. Now look at the two equations. Which transformation will map y is equals to cos x, that is the curve, to y is equals to 2 cos I have x? So we need to think of all the transformation that we know, but you need to have at least an idea of each and every transformation and how it behaves and how it is. So there are others that of course will not be applicable in this case. So after a keen look at these two, you would notice that in the y-axis the curve is moved from 1 to 2, and then again on the x-axis you'll notice that there is that movement parallel to the x-axis. So there is a movement both in the y and in the x-axis. So you think of which kind of transformation that can be, and you'll notice that this one is definitely a stretch. A stretch in both axes. One is parallel to the y-axis, and then the other one is a stretch parallel to the x-axis. So that is the transformation, because you can see it has been stretched. The first curve begins from 1, then has been stretched to 2, then on the x-axis from 90 to 180, and you can see there's a stretch factor there. So this is a stretch factor of 2 from 1 to 2, then from 90 to 180 degrees. So you can see that is a stretch of 2. So this is how we describe the transformation, that this is a stretch, this is a stretch, this is a stretch along the y-axis, followed by a stretch along the x-axis with a stretch factor, the stretch factor of 2. So that one is fully described by giving that. You have noticed on the y-axis you can see moving from 1 to 2, that is a stretch of factor of 2, then from 90 to all the way to 180. So that is how you identify that. The next one is part 3 of the question, the values for which cos half x minus half cos x is equals to 0. Now when you look at this equation and look at the curve, you notice that this one is definitely giving cos half x, that you can see is an equation there. So what you need to do in order to ensure that these two be able to identify the values for which these cos half x minus half cos x is equals to 0, to give the values, you need to do some working here. So if you multiply this by 2, if you multiply this by 2, this every term by 2, you will notice 2, you'll get this 2 cos half x minus this will give cos x is equals to 0. Now you don't need to put this bracket here, you can remove this bracket. So cos I have x. So there's something that you will notice by just a keen look at this. You notice that this one, you'd notice that this is the equation of the two curves. This will give by multiplying each time by 2, you will notice that cos 2 cos half x is the equation of one curve there, and then cos x is the equation of the other curve. So that was the purpose of multiplying by 2 in order to get those curves clearly. Now this one, you can also take this one, 2 cos half x is equals to cosine of x, if you can take this one to this side. So how do you solve this? To solve this graphically, when you're equating the equations of two curves, you definitely check the point where the two curves are intersecting. Where the two curves intersecting, look at the curve. They're intersecting at one point only. There's only one point where they are intersecting on the curve, and that is 210, just between 210 and 240. So that will be around 225 degrees. That is the point of intersection of the two curves, 225 degrees, and that is the value. The value of x, therefore, will be 225 degrees. So that is how you're supposed to work out that. Since the point of intersection is only one, then that is how you're supposed to work it out.